Sorry, just trying to find my mouse. I'm over here now, yes. Right, there we go. Bit of housekeeping. This event is being recorded and will be made available to everybody who registered for this webinar, and it'll also be uploaded to YouTube to be found later. All attendees have media disabled for a smoother presentation, so you can't speak or present, but you can write in the chat and write in the Q&As. Everyone who attends the event will automatically receive a CPD certificate, so long as they've attended a certain percentage of the webinar. All the questions, please can you submit them through the Q&A tab. The Q&A tab is preferred to the chats tab. It just makes it easy for us at the end of the presentation, and all questions will be taken at the very end of the presentation. The slides will also be made available to everyone who has registered for the event. All speakers have confirmed that that is possible. And please do not use any AI chatbots. If anything comes up, we will automatically disallow them. No chatbots required, allowed. So IMechE is the Institute of Mechanical Engineers, and we have various different subgroups. The two that I mentioned before was the Process Industries Division, which water and wastewater comes under the banner of. And as I mentioned, we cover other process industries groups. And we try and organise as many webinars as possible, just try to spread the word and spread the communication and educate and enhance the community. IMechE has an equity and diversity and inclusion policy. You're free to read that on our website and in these slides later. Now on with the presentation today, the webinar today. I am Pamela Robinson. I'm a chartered engineer with the Institute of Mechanical Engineers. I'm a senior mechanical engineer within United Utilities. I've been here for about 3.5 years now. And with me today, I'm joined by Rob Drury, who's our Better Rivers Capital Delivery Director, also at United Utilities. Rob previously held a series of influential roles on some of the world's largest and most complex and challenging projects. Rob has worked in multiple business sectors in the construction industry, namely oil, gas and chemical, aviation, rail, pipelines and telecommunication, both in the UK and internally. But here at UU, it's part of project investment of over £1.5 billion to be spent over 5 years, improving our CSOs. Joining us today is also Ben Murray, who's going to do some presenting for us on storm overflows in the Sunwater region. He's been with Sunwater for the past 2 years, working in this particular area. He's driven by a strong passion for environmental protection and community engagement. Ben plays a key role in raising awareness of our efforts to reduce storm overflows. He regularly delivers information talks across the Sunwater region, helping customers to understand the vital work being done to their environment and their waterways. And then joining us later as a panel member is Simon Fosbraey, who's also from Southern Water, and he's a senior storm overflow engineer. Simon's background in engineering has been very varied over the years, and it all started as an aluminium TIG welder. It led him on to welding and fabrication for a company that dealt with global companies in the pharmaceutical, food and fuel industry, among others. He eventually moved into a role incorporating all aspects of engineering as project engineer. He's had a wide variety of many jobs in many industries, including marine, gas, manufacturing, food and building. And he's took on this current role in Southern Water to make a positive change and difference to the environment after coming from roles that could be seen to be negatively impact the environment. He's now leading the team of engineers and technicians in finding the sources of excess water that contribute to our CSO release, and then find the best and most appropriate solution to removing or slowing it down. There are speakers and panel members for today. Now on with the webinar itself. First of all, we're going to describe what are combined sewer overflows, CSOs for short, why we need to reduce these spills, and the methods that we're taking to try and reduce these spills. We're going to discuss the future scope that we've got, and then we'll do all Q&As at the very end. So, why have we got combined sewer overflows, combined sewer overflows. Well, as you can see, from our houses and our industries, the dark line, we have sewer connections into our sewer networks, and they join larger connections that then go on to our wastewater treatment facilities for treatment, and then the treated effluent is discharged to our watercourse. However, we also have a lot that are cross-connected with surface water drainage, and this is fine up till a point. However, when it rains, the capacity of the combined sewer only has a certain capacity. And then as it rains and as it rains further, we need to have a pressure relief point, and that's what combined sewer overflow is. It's a pressure relief point. If we didn't have this pressure relief point, the sewer would back up back into our homes, pop manhole lids, and cause flooding in our residents and industry. We need to have this pressure relief. Each of these DSOs is a permit, is an agreed permit with the EA, and it's an agreed discharge point. And with the most of these combined sewers. Now, at that spill point, we have many of our sites, we have screens. So it isn't just released straight stormwater, it's actually screened 6 mm in 2 directions. Now, in the bottom right-hand corner, you can see an example of a static screen. So basically, the sewer network runs underneath it, and as the level rises, as it rains, the storm flow goes through the static screen, the peaked static screen, and it's screened to 6 mm in 2 directions, and the overflow goes through the pipe in the top right-hand corner. And it retains the bits within the flow, basically retains all the screenings. Over on the left-hand side is a powered screen alternative. The flow coming through the network, you can see on the right-hand side of the picture, and then as level rises, the storm comes up through the screen, through the bottom of the screen, and then out on the overflow on the left-hand side. And that's the storm discharge. The screen itself has a little wiping mechanism that continually wipes the screen clean to try and keep the screen clean so it can carry on screening and doing its duty, and flick the screenings back into the continuation flow, which will then go to the sewage treatment works, and the screens will be taken out at that point. How we're looking to reduce the spills, because we have many CSOs across the country. We're modelling all our networks to basically a 2050 design horizon, and we're including climate change to work out where we're spilling, how frequently we are spilling, so we know where to prioritise and hit the highest spillers first. We're looking to try and get the spill events so that we can it can be less than 10 times per annum from that spill point. And the methods that we're going to look at, and we'll try and prioritise is, can we reduce that surface water entering our combined sewers, so that when we do have a rain event, it doesn't impact our sewage pipes. We're looking at reducing infiltration of those existing pipes. Some of those pipes are really quite old now, and we have infiltration. We're also looking to build in storage. So where so when there is a storm event, we hold the flow back in a tank or some kind of storage, and then when there's capacity in the network, release it back in. And then the other option we look at is, can we actually just put more flow through our sewage treatment works and treat more of that storm flow at our sewage treatment works? And then the picture on the right-hand side is just a snip of a little network map of ours. Now, all the pink lines are all combined. So that's the amount of combined sewers. So basically, the surface water and the foul is mixed, and it goes into the same pipeline underground. The yellow pipes are foul only, and the blue pipes are surface water only. So you can see in that little snip below how much is combined and what the little pockets of separated sewers system there is that we have to deal with. Now I'm going to hand over to Rob, who will go through some of their examples.
Okay, afternoon everybody. Yeah, I think what I'll do, I'm just going to touch very briefly on various examples, some theoretical and some real life examples today, and I'll try not to overlap with some of the content that the guys from Southern are going to cover. Talk about, if you like, never allowing the rainwater into the system, and you know, this is again examples of water butts, and there's more content later. I think the issue with these at small scale, these really are just a token effort. So that, you know, there tends to be an element of publicity with these, where we can locate these at some strategic and visible places, which is, creates a positive image. But the success of water is really at scale. It's at the hundreds and it's at the thousands. Now, that brings its own challenges of deploying at huge levels of scale. It can be done with larger premises, at large commercial premises, where again it's more successful. But generally, the rollout of this kind of thing at scale is particularly tricky. Because of we're talking about hundreds or thousands of customers, but again it all contributes. So the less we can get into the system, the better, and the lower volumes of water that we have to cope with it within the system. And then we've got, as people like to call it, SUDS, so sustainable urban drainage systems. And again, these are real systems that you're looking at on the screen. That's in Altrincham on the left-hand side. So again, these are all, for the people that are not familiar, you think, oh, well, the local council and local community are installing tree pits and the like. And really, these are all systems that, again, prevent that rainwater getting into the system. You can see there's a scheme on the right, which is that's a theoretical scheme at the moment. So that is a scheme to go. That will be going live later this year. We're hoping to start work on that in December. That's in a place called Noctorum in the Wirral. Again, I suppose it brings two. It brings the subs element to it, but it also brings traffic calming. So it's a nice way of bringing sort of double benefit to the community. These are particularly difficult to go and install because it's much easier to go and do work on some tanks in a brownfield site. As soon as you're into communities, depending on what the community is and the appetite for whether it's traffic calming and the associated stuff. So again, difficult to get going and difficult to start, but again, very visible and a real positive in not allowing rainwater into the system. And then this one isn't ours, but again, give you an idea that within these huge networks that we've got, by really automating the system, and I'm going to say more in probably a petrochemical kind of a way, there's an opportunity to use existing capacity within the network. So, typically we've got, huge diameter pipelines that interconnect, across counties and regions. And again, by automating the valving and the pumping and having that a little bit more sophisticated, there's opportunities to create hundreds, and in some cases, thousands or 10,000 cubic meters of storage within the network. So again, that's about maximising what we've already got. Almost in a sort of use Thames Tideway as an example of how that would work. But again, it's how we prevent building new and maximising the sophistication of the old. And then we've got the here and now. So this is one of our signature projects right now. So we focus right back into more traditional construction. So this is a 12,500 cubic metre tank that we're building up in the Blackburn area. And you can see the scale of the excavator in the middle there. And when all else fails and we can't prevent the ingress of water into the system or the network, and we can't fix it all with SUDS, we really are forced to go and build huge levels of storage. This is one of our bigger systems. So again, at 12,500 cubic meters for a tank. This is on some of the bigger sizes. We have bigger, but again, you can see. These are not typically easy to build. You would never choose where to build these. They're always in places that you wouldn't really want to build. Actually, this is probably one of the better ones. We have some incredibly constrained sites. But again, you can see the magnitude and the variance between some of the things we were looking at before and and then the underground shaft type arrangements that we've got. And then we've got above ground storage, which, typically if we're looking to do work on an existing wastewater treatment plant, that is often more viable because, we've obviously got development rights within the actual site. Again, the visual impact and just the physicality of some of the sites of the tanks that we have, you can see the impact there. And again, that is all about the aesthetic treatment of the site to manage minimise the visual impact. This is a site in Lytham, and again, it's next to an existing pumping station. It's next to a commercial. If you looked onto the right far right, there's a big commercial semi-industrial estate. So again, a better opportunity to go and build something that's more industrialised. And again, we have others that are right, adjacent to schools and communities. So the impact of that is just not possible, and we would then be forced to go to something that's that you saw on the previous slide with the underground tanks. And then we've got this is a scheme that we've been talking about for a while. This was something that was badged as the Fire Tunnel. So again, much similar to Thames Tideway. So again, most people are familiar with that and the documentaries that exist with that. So again, rather than constructing individual sites and individual tanks and individual network enhancements, this is really about stitching together all of those sites. So this was a scheme that stitched together potentially 19 CSOs and also some emergency overflows. So really quite an elegant solution, and also we have been thinking about the local community. The disruption really minimal because the disruption becomes over a relatively short period of time rather than as we've got there from AMP8 going on to AMP9 and 10. So again, the disruption is less, and the tunnelling again is less because we're doing it over 3 or 4 tunnel drives rather than building lots and lots of tanks. So again, if you like, a much preferred, but can be again huge capital investment. So once this from a bit of an adventure and something that takes a fantastic picture, can be extremely expensive solution. And then we've got again another very basic where we talk about online storage, and again, if you think about how we upgrade sections and pipework, so it might sometimes it's as simple as going from you could say a 24-inch main up to a 36-inch main or a 42-inch main. This is where we're utilising a culvert. So again, I think in this case there was a 16-inch main that we then expanded into a culvert. So we run a box culvert, and we run it down an existing easement. And actually, the easement has got a dog leg in it, and we dog leg the culvert around that as well. So again, creates additional capacity within the network, and again, as we would badge that as online storage. So very unsophisticated, but very very effective. We have a lot of this up in Cumbria, where again very very small areas, huge access constraints. That if you'd really be looking to get nothing more than a Hilux pickup on some of these roads. So getting plant and equipment and materials is a real constraint. So building it becomes the easy bit. Getting to the site and constructing it or the access is probably the real challenge. And then we've got increasing the capacity. So if we again where we have situations where again it's all about balancing what's the best possible scheme, and sometimes it's easier to increase the capacity of the existing treatment plant. And we've done this particularly for low capacity sites. So again, what these are modular pieces of equipment that again it's basically a modular treatment plant, side stream treatment plant as it's called. So again, that takes what might be a 5 litre per second facility, and we can add another 5 litres per second. So we can maybe double the capacity of the treatment plant to actually deal with all flow. So again, it doesn't provide storage, but again, it treats more And again, these are particularly useful in the areas of Cumbria, where again we have lots and lots of very small sites with very low flows, in sort of very spread out communities. So something that's just not viable, in centre of Manchester and the like, because again the flows are huge. So this is just something that's particularly tailored to some low flows. And this from a rapid deployment perspective has been quite a speedy and quite a successful solution. And then we've got wetlands. So again, this is something that we have examples of this, where again we're able to very, very green, something that we would prefer to do more of. Again, there's discussions with the EA and Ofwat about how this becomes a much bigger deal, probably later in AMP8, but certainly in AMP9, which will be 2030 onwards. So again, rather than going through process and going through huge levels of storage, we're able to go through a green level of treatment before we put the treated water back through into the water courses. So again, what we've got there is we've got all these different combinations of solution that really, I'm not saying it's a lottery, because it's not, but it's about picking the right solution that is typically about the area, the geography, the topography, the capacity, and again, what's most economically viable. And then I think this has got a whole load of things on, so I'll push all the buttons. And this one is one of our bigger sites. And again, I think this is quite interesting, because whilst it's already a big treatment works, there's opportunities here to, one, increase the capacity of the work. So again, we're talking about additional treatment. There's two, additional storage. So we will have large scale, tens of thousands cubic meters of above ground storage. But also what we'll be doing is we'll be linking in other overflows. So much like the tunnel solution, as I mentioned before, this will also link in probably 3 other overflows. So we've got a network solution that links in 3 other overflows, a level of network upgrade and upsizing to give us network storage, some additional treatment capacity on the site, and also storage on the site. So this plays, if you like, with 3 or 4 of those potential solutions to give us an overall build, which is one of our bigger CSO schemes. Oh. And then I think I just put this in just to wrap up, just to give you maybe the magnitude of this. So, whilst some of those schemes don't look that significant, what it looks like for us today, so we have over 400 of the overflows that we're dealing with in the next 4.5 years. We are structured regionally and sub-regionally and locally. There isn't necessarily a plan of course, it's a plan for the overall portfolio of work, but it is very regionalised. Different things matter, and different things are more important in different areas. We have obviously a large coastline, so we've got bathing water restrictions and again, higher levels of criteria that we need to satisfy. We are desperately running very, very quickly to modularise and standardise solutions. So we have standard designs, standard solutions. You saw some of the modular equipment that we were using that we've sort of developed, reverse engineered some stuff. So modern methods of construction, DFMA, that we really want to plug and play a lot of this where we can. Building large storage tanks bespoke in a bespoke way isn't really the future. It's not really where we want to be. So again, it's fitting those design modules and solutions together. Because of the 400, obviously we have to go quick, and we're going quicker than we've ever gone before. And I think also the connection to the customer that I mentioned at the bottom. So, whether you live in central Manchester or a village in Cumbria, we're also trying to link now from a community perspective. People, as they get the bill, they get notified, and there's obviously an awful lot of comms about what we're spending, what benefits they're bringing, what the level of work that will be going on within that particular area, what their opportunities are for apprentices and for graduates, and for other people within the organisation. So it's just not making it. This is a cost to the customer. It's about there's the direct benefit to the customer, and again the communities. And again, there's a very crude on the right, a hierarchy of opportunity, and if only each one of those fitted nicely into each of the schemes, it would be great. And as I mentioned earlier, often it's picking a number of things that work in concert together to give us that spill benefit. So interesting programme, lots to do. The one thing that we have to do is go quickly because we only have the 5-year programme to complete 400. We're expecting that AMP9 is probably bigger than that. That will be 30 to 35. So that just gives you a quick snapshot on what we're doing, scale of the problem, and then I'll hand over to the guys at Southern who can, I think they've got some specific details that will probably hopefully play to that. Okay.
Excellent. Thank you, Rob. Hi everyone, my name's Ben, Storm Overflow Engagement Officer with Southern Water, working on the Clean Rivers and Seas Task Force. So I'm going to be telling you about the sustainable drainage solutions that we've been able to implement across the Southern Water region. Our focus is more on trying to tackle the problem at the source as opposed to just focusing on the endpoint. If we can tackle that problem at the source with the amount of surface water, rainwater and groundwater that's going to our wastewater treatment works, we can help to lock out that surface water and groundwater. Yeah, that's going to be beneficial for us because at the moment we're in a climate where climate change is present, rainfall events are heavier. So if we can lock that out at the start, it's going to be beneficial for us. Surface water and rainwater can be up to 80 times that of the foul flow. So beneficial for us to lock that out. Next slide, please. So we're going to be focusing on the first point, which is locking out surface water and rainwater. So we're going to go on to the next slide there. The main focus of what we're trying to do here is we've been able to look at 5 different steps that contribute towards locking out surface water and rainwater from our network. I think I'm still seeing the previous slide. If we can go on to the next one, that would be good. Yeah, so we break down here into 5 different steps. So the first one, optimizing infrastructure, tackling surface water connections into our sewer network, installing sustainable drainage systems on homes, that's our slow drain water butts, installing sustainable drainage systems on businesses and community buildings, that's our rain planters, and then working on highway schemes with the local councils. So next slide, please. So if we look at that first example there, looking at optimization, the example we've got here is where we worked at our Swellcliffe wastewater treatment site up in North Kent. We were able to change and challenge the permit from when we first began to utilise the storm tanks on site. So the full flow to treatment, which is the maximum amount of flow that site can treat at any point, is 205 litres a second. Now, it used to be that the storm tanks, the first 2 storm tanks, would only start activating once the flow coming into site reached 760 litres a second. We were able to challenge that permit and make sure that we actually begin utilising those storm tanks right at the start. Once that full flow to treatment has reached that 205 litres a second, that's then allowed us to save on storm overflows by 36% at our treatment works. Next slide, please. So moving on to the next point, fixing surface water connections. So the example we've got here is where we worked down in Portsmouth, worked on a street called Old Turnpike Road. What we found is that the surface water that was coming from the houses should have been going into the surface water line that was in the road. Now, obviously, as we know, a lot of the network is combined. But we do have some parts of the network that are also separate, where you have your own surface water line and a foul line. What we found here was these houses, their roof drainage, instead of going to the surface water line that was already in the road, it had been incorrectly plumbed into the foul line. So when it was raining and raining heavy, all of that surface water and rainwater was going all the way down to our wastewater treatment works. So we were able to separate the roof drainage from 34 properties, which has then helped us to lock out that surface water from going to our treatment works. So we liaise with those households, we engage with them, and then they work with us to allow us to redirect their roof drainage back into the surface water line that it should have been going down in the first place. Next slide, please. So moving on to the next one, household suds. So what you see here is a picture of one of our slow drain water butts. Now, slow drain water butt is a little bit different to a normal water butt. About halfway up the water butt, you have a small slow drain pipe. What that means is in the winter months, when that water butt would otherwise be sat there full, it will slowly drain away. The top half will slowly drain away over a period of about 6 hours. Yes, it will go into the combined network, but we're slowing the flow of that surface water from going into the combined network. How is that helpful? If we can flatten that heavy peak of rainfall, that's going to reduce the impact on our wastewater treatment works going forwards. Because that water butt is slowly draining away over a period of 6 hours, it then means that we regain that capacity for when it comes to rain again. So instead of it just being sat there full, especially in the winter months, it's allowed to drain so we can regain that capacity. Now, I know that Rob mentioned earlier that in isolation, how useful is installing a slow drain water butt? Well, yeah, it may be more of a token effort, but en masse, it can be useful. And we found that installing these slow drain water butts in the Isle of Wight, we worked in a small town called Haven Street, and we installed 130 of these slow drain water butts. That helped us to reduce spills at the local pumping station by 70%. So it was very effective for us in that Pathfinder area. And it can be a solution where some of the other things that we're looking to implement might not be a specific option. Moving on to the next slide. The next one here is non-household suds. So this is more focused towards community centres, businesses, schools. So at Southern Water, we were able to work with the Department for Education. So we worked in partnership with them, and we worked in over 100 schools to install big rain planters, as well as installing suds like what you see here in the picture, swales. The rain planters obviously help us to lock out that surface water from going into the combined network. That's great for us because it helps to reduce storm overflows. But the benefit for the schools was it helped to reduce localized flooding, helped to teach the children the importance of planting for environmental sustainability. And we didn't just stop there. We made sure to go in and actually explain to the children and educate them on why a rain planter is useful at their school. What are the different benefits? Just to get them thinking, just to get them understanding, and prove to be beneficial. They can go back, they can tell their parents, why is it useful that we have this? What are storm overflows? How do they work? What are some of the other issues associated with flooding? Yeah. So really, really useful. And yeah, it's been a very successful scheme, that one for us. Next slide, please. And then our final solution to blocking out surface water and rainwater is working on highway schemes. So again, I know Rob showed a few examples earlier on. We've got similar examples of where we're working with local councils around the Southern Water area. So we've currently got 3 highway suds leads that work within the Clean Rivers and Seas Task Force. They're split east, central, and west across the Southern Water region. Their jobs are to liaise with the local councils and to work on trying to find synergies where we can collaborate with the councils to install sustainable drainage systems. Yes, that's going to help us with reducing storm overflows. It's going to help us to reduce runoff into the combined network, but it's also going to help the councils reach their own targets. So by doing this work, what some of the things that we're looking to implement, things like swales, things like tree pits. Obviously, what's a swale? It's like a green area that sits off the side of the road. That surface water runoff can go into the swale, naturally permeate out into the environment. It will also provide a natural form of treatment as well, having that. And then tree pits work in a bit of a different way. They have a basin that sits underneath the tree. That will then fill up. And then there's a small slow drain pipe that allows it to slowly introduce back into the network. Again, we're slowing the flow of that surface water. So some really good work going on there. Next slide, please. And then we now move on to the second challenge that we experience in parts of our catchment at Southern Water, which is locking out groundwater infiltration from the network. So if we go on to the next slide. So how does groundwater actually get into parts of our catchment? Well, it's important to recognise that this isn't an issue across the entire catchment. It's only some areas that will suffer with groundwater infiltration. And that's because the rock that the ground sits on in some areas can be impermeable. And what that means is the groundwater level will sit a lot higher. When it sits higher, that pressure from the groundwater in some cases will then find its way in through gaps in the joints of the pipe. So you can see on the picture here, that water that's coming into the sewer, that's groundwater. And the sewer there is perfectly healthy, but it's just that pressure is finding its way in through the joints in the pipe. That's obviously not helpful for us because then we've got a constant stream of groundwater going to our wastewater treatment works that we're then having to treat that we otherwise wouldn't need to be. So if we move on to the next slide, we'll be able to tell you about a specific example and then what we were able to do to lock out that groundwater. So what did we do, and where was the first case of where we were able to lock out this groundwater and solve this this problem? Well, we worked in a small area called the Pan Parishes, so it's made up of 3 small villages: Kimpton, Thruxton, Fifield, near Andover area. We were able to implement a no-dig solution that allowed us to put a packer down into the sewer, and we'd have a fiberglass and a resin material that goes around that packer. You insert it into the sewer, you inflate it, and then it will stick to the walls of the sewer. You allow it to dry for 45 minutes, and then you can remove the packer. So you don't actually need to dig up the pipes to line the sewers. Yeah, it takes up a really small amount of the sewer. What did that mean? In the Pan Parishes, we used to have 30 tankers a day going into those 3 small villages, removing excess groundwater from the sewers. Yeah, obviously with 30 tankers a day, very disruptive, a lot of traffic, a lot of noise, unhappy residents, a lot of cost. Through lining both the public and private network, 4.5 kilometers of it, after doing that work, despite having near record-breaking groundwater levels, we've now not had any tankers back in the area since. Really, really powerful case study for us. And now this is paving the way for doing more of that, locking out groundwater in some of the other catchments that then suffer with that same issue. So a really powerful catchment, and it's now paved the way for what we're going to be doing going forwards. I think that's the last slide from me. Excellent. Cool. So I'll probably hand back over to yourself, Pamela and Rob.
Sorry, we're just finding the mute button. So thank you very much for that, Ben. And thank you for giving an insight of what's happening down in Southern Water as well. Now let's just move on to the questions. If we start. Oh, yeah. How big is the problem of land and illegal cross connections between the foul and the surface water connection? Do you want to?
I can pick. I mean, I'm sure it's that we can probably all contribute. Yeah, a huge problem. This disconnection, again, probably wasn't mentioned, but disconnection plays a massive part in what we're doing, because we, not just illegal, but just, I mean, the example before, it's almost like the mistakes. We have lots of fields that seem to be draining into our network. So, the better the intelligence that we've got and being able to go back into those networks to disconnect those, but they've got also to be, disconnected in the right way, without creating other problems. So again, the flooding issue about what may be result from that is a particular issue. But generally, yes, it is an issue. Yes, it is something that we can benefit from a spill reduction perspective. So again, we pursue that constantly, and clearly we have parts of the network that have existed for over 100 years. So there's things that are found that are 10 meters deep that nobody ever knew were existing, just because of the age of the infrastructure.
Ben, I can see that you want to answer that question as well. Just take yourself off mute.
Yeah. I was going to add about the fact that, just kind of seconding what Rob's saying, the fact that it is an issue, and what we've been able to do at Southern Water, we've been able to hire specific illegal connections engineers. Their job is to work in those specific areas where the bathing water might not be as good as others. Their job is to then work proactively to try and find instances where there may be these illegal connections. So they work out on the catchment, they'll do dye testing, try and find instances where there may be that foul going down into the surface. They found there was a really, really good case study that we had not too long ago where they found a block of 15 flats that had their sewage plumbed down into a surface water line. So they were able to work proactively to find that and then rectify the connection back to where it should be going. So it is an instance where that can happen across our catchment, and they're working kind of all around it to try and work proactively to find where that's the case.
Thank you, Ben. On with another question.
Simon had got his hand up.
Oh, Simon, did you put your hand up? Sorry, did you want to add anything?
Yeah, I did. I was just going to say on actual surface water connections as well, we found quite a lot where we'll have a surface water network that looks fine, but further on down the road, it's actually just carrying it to another location within our wastewater or foul network. A lot of these connections seem to be because they've been added over time and either levels don't quite work out for them. So the easiest option is to just go straight into the nearest pipe, which would often be the wastewater network. But if you look at it a bit further on, there are other connection points, which probably at the time would have been more expensive to explore, but we are removing those surface water connections into our foul and rerouting them to where they should be. We're constantly on the lookout for them. We've developed a program that will look on the mapping to highlight them as well. So yeah, we are slowly dealing with those surface water connections to foul.
Thank you, Simon. There's another question on there. It says, how many of your southern water sites comply with the 65 litres a head of population storage request capacity? And how many sites rely on the 2 hours to fill process? Well, all our foul networks are designed to the minimum 65 litres per head per population. It's the fact that with the combined with the rainwater, that's where we reach capacity and exceed that capacity. And the 2 hours, I'm pretty sure all our networks are suitable for the 2 hours as well. But again, it's how much rain falls and how quickly that rain falls. So the 2 hours is a little bit negotiable. And Ben or Simon, did you want to add anything to that?
Not particularly, apart from just reiterating the point that you've made there about how much rainwater's in the network, and the impact that then can have on our treatment works with how quickly storm tanks fill up, etc. Obviously, it's going to be very dependent on that.
Thank you.
Yeah, I was just going to give a good example of the extra water that we have come in. That reconfiguration that we've done at our Swalcliffe treatment works there. As Ben said, that site is treating 205 litres a second every day. It can treat that, no problem at all. The problem is coming from the rain, like we say. So that site, just to give you an idea of how big the problem can be, 205 litres a second, what it can treat. We have over 1,000 litres a second coming into that site sometimes when it's really raining hard. So that gives you an idea of the jump that we're trying to deal with from that extra water.
Thank you, Simon. Another question. Are wetland storm overflows all receiving screened storm overflows?
So the answer, we've got two wetlands of any significance, and the answer is yes. They're screened as they enter the wetland. So probably we can skip through and get a few more questions.
Yeah. How many suds bins are needed in lieu of a large storage tank? Does Ben or Simon want to take that? Oh, Ben does. There you go.
Yeah. Well, that's obviously going to be. It'll be very dependent on how big the storm tank is. I mean, obviously, our water butts are about. I'm right in saying they're 200 litres. Is that right, Simon?
Yes, they are 200 litres.
200 litres. And then obviously with regards to that, you've then got to think about the fact that they then have that slow drain element in it as well, that then allows you to regain capacity. Obviously with regards to a storm tank, you've got to remember that once it's full, you then have to empty it as well. And you can only empty it once the site, once you go below the full flow to treatment at site, and it's then has the capacity to be able to then empty that storm tank. So there's a lot of, it's very difficult to kind of measure, but it's important to understand those benefits. And how if we can actually just lock it out in the first place and stop that surface water going down to the process, we then don't need to then even look at repumping that water back through the site. If we can stop it from the first place, that's going to help us to reduce the impact on the site, which would then lead it to needing to go into those conditions where they do utilise the storm tank.
Thank you, Ben. Another question on that is, what is the expected lifespan of the linings? And what plans are in place for replacing them, so of the ongoing lifespan of them? And do you know what the problems of failing linings will cause, and will it cause a blockage? Thank you, Ben.
So with regards to who we do this lining with, so we use a company called Vortex to do the lining out in the catchment. So it's made of a fiberglass and a resin. They've told us that it should be about 50 years of lifespan. With regards to the impact on blockages, because it's only taking up a small amount of the sewer network, there aren't any real impacts on that. Also, the material that it's made out of is quite a it's made out of a resin, so it doesn't really kind of stick to that. It's harder for it to stick to that resin material. So therefore that's going to help us to reduce the impact of the blockages there. With regards to the plan for failing linings, as far as I'm aware, we've not had any real issues so far. And therefore, to my knowledge, do we have any plans to solve that? To my knowledge, I'm not entirely sure. That's something that I'll have to kind of take away with me and get back to you on.
Thank you,
Just on that, we have had a lining fail before, an installation, and unfortunately, the way that they had to deal with it was they had to dig up the pipe. If we didn't use lining, though, the way that we'd have to lock the water out again, it would have to be by digging pipes up. So the lining is a really good way of causing as least disruption as possible and having a big impact.
Thank you, Simon. There's another one, sorry, it is aimed at Southern. We also have a Southern customer on the line. Somebody was forced to install a soakaway and a one-way valve flow diversion for rainwater at his house for the rain. To back up the peak flows and high tides. The discount on his sewage charge is not much of an incentive to invest in this way. Are there any plans to improve financial incentives for home rainwater soakaways?
So with regards to the areas that we're working in to install SUDs, those are the areas that are our priority areas. So Ofwat will obviously dictate how much we have to invest in those areas. If I was to give you the example of the work we did down in Portsmouth, the locking out the surface water from going into the combined sewer, that work to manage that rainwater runoff. Well, that's come from the fact that that's one of the priority areas that we need to work in. So therefore, we were actually able to front the cost for that specific work. So it's going to dictate on what areas we're actually working in, and therefore, if Southern Water are then able to implement the solution.
Thank you, Simon. Did you have anything else to add?
No, that's fine.
No, that's fine. On to the next question. In our geographical area, there have been issues with the county council and developers, and they can't agree who will take responsibility for the maintenance of the large-scale SUDs associated with the large housing and industrial developments that are ongoing. Do the water companies or Environment Agency have any say on ensuring this maintenance is undertaken so that it doesn't impact in future on preventing future stormwater flooding back due to the lack of maintenance of the SUD?
So I showed that there was a slide of a site that we're working on or we've been working towards in the Wirral. This is incredibly difficult. So to make this happen, the level of effort to get agreement with, again, local councils and everybody else and developers is almost beyond the point where you would elect to build a great solution, which is not really where we want to be as a business. As a business, we want to develop great solutions and SUDs. So that has been really intensive. I would say that, there's times when there's no great desire from a local authority to want to actually install some SUD schemes. So this has really been about the tenacity of the people that are involved to make this happen. We believe that we're fairly close to that. And again, obviously, all the idiosyncrasies of who's best placed to maintain in the future, ownership, etc. So I wish there was a straightforward answer, and I wish there was a straightforward path to getting it all done. There isn't, and it varies by council, parish council, local authority, LEP, whatever it is. And again, it's really about us being agile enough to make that go. Some places it's just not going to happen, and other places there's more proactivity to make it happen. But yeah, particularly difficult, and it's not a set. It's not a set path at all.
Ben or Simon, did you have anything else to add?
Just basically we find exactly the same thing, unfortunately. Suds is obviously a nice green solution. It looks nice, and we would like to put in a lot more. Working with the authorities, it is often the maintenance part. We are working with them to do the maintenance as well, but we also find from borough to borough, people that are accepting of one thing, the other borough will flat out not accept the same thing as the other. So it's quite a minefield to negotiate, but we are making progress. We have got some suds in the ground as well with authorities, so it can work. It just depends on who they are, and it is an ongoing process.
Thank you. Another question. Does it make a difference to the wastewater treatment works if it's a continuous or a batched process? I can take this if you want.
You take it.
The wastewater treatment works are consented for a continuous flow with a peak flow requirement, and that's part of the EA consent and the consent on the works. So if you decide as a water company to process that incoming continuous flow in a batch process, well, you have to have sufficient storage up front to enable the batch process to proceed. So it doesn't make any difference to the sewage system. Did anyone else have anything else to add? Or nope. How do you tackle Legionella bacteria issues if it's present in your network? Southern, are you able to offer?
Yeah, unfortunately, I have no idea on that question. I don't know the answer.
Same. Bit more of a process science question, that one.
Yeah, it is. Yeah.
Say it's a process engineering question.
Speculate.
I'd speak it to, yeah, I'd just be guessing. But if it's present, we would treat for it in the sewage treatment works. What requires water companies to prepare their works for the extra requirement caused by the 1.7 million homes? The Grampian regs can delay occupation for 3 years, but what requires the water companies to be prepared? I ask this knowing that water companies will charge the new customers monthly forever, so investing is key as opposed to trying to pass this on to AMPs, etc. For every 1,000 homes, the companies will earn 50,000 per month indefinitely. Would you like us to deal with that, Simon or Ben, or do you want us to?
Go on.
Yeah,
Yeah.
good, and then I can.
Yeah, okay. Well, when extra home developments come in, they have to run it past the water companies to see what capacity we've already got in our networks from both a water supply point of view and a wastewater treatment point of view. Obviously, new homes, the requirement is put on that the surface water is dealt with separately. We touched on earlier about the SUDS aspect, and so that each housing development should have its own SUDS. So all we have to deal with is the foul water side of things. And then once we've established if we've got enough capacity, if we have to build extra infrastructure to deal with that capacity, that has to be passed back to the developer to actually help contribute to that cost. However, it's done at such a high level, it's very difficult for us to assess how much of an impact it will have until we've actually gone into more detailed design. So there's that aspect of it. And then as for the ongoing money, because we've got extra homes connected on, it doesn't cost. It costs money to treat your sewage, and it costs money to give you treated water. And that's what the money that you pay the water companies goes towards. It goes towards maintaining those assets, not necessarily building the infrastructure in the first place for new builds, but it goes towards maintaining and keeping that asset going and feeding it clean and dirty backwash. And we realised the time, so we'll just we have one last question. Do you have any plans to incentivise rainwater harvesting and three-pipe water use in buildings? Does anybody know of any incentives being run in the companies? Ben?
Yeah, I mean, this isn't solely mine or Simon's area, but at Southern Water, we have a specific water efficiency team. The idea of the water efficiency team is to go around the catchment and try and implement well, water efficiency. And they'll do that through working with businesses, working with households. At the moment, they're prioritizing the Hampshire area where I believe they're doing kind of business visits to try and help businesses obviously save on money, but the big thing is save on their water usage, which is then going to be more beneficial for water security going forwards. I believe after speaking with them recently, they're set to start a new contract in the early new year, which will then change where they're going to be working going forwards. But that information's still to be confirmed. But there is stuff that happens. We've got our own team that look after that at Southern Water.
Thank you, Ben. Thank you, Simon. So before I move on from that, sorry, thank you very much for Rob sat beside me and Ben and Simon across on the Teams call. It's provided a very good insight into what CSOs are, and your knowledge has been greatly appreciated on that. And Simon again for adding responses to questions at the end. All the recordings are available on the YouTube that I mentioned at the very start. You can access them via that QR code. These slides will be sent through to you all if you're not quite quick enough with your phones. And then just on with some future events. So later this month, next month even, we've got Measuring Methane in Agriculture, another lunchtime webinar being hosted by the Process Industries Division. So we're on the 5th of November. And then we've got another one, Managing Climate Risk and Adaptation Using High Resolution Modelling, that's on the 13th. And then another one that's coming in before the end of the year, 27th of November, an insight into hygienic process design for engineers across the brewing, food and beverage industry. And if those take your fancy, please go and visit the IMechE near you website, or you'll be able to register interest and register for the event. And we look forward to hearing from you. So again, there's another QR code for you. You will automatically be sent a CPD certificate for attendance to this webinar, should you want to keep hold of that. If you have any other questions about the webinar that's been run today or any future webinars that we've got, please do not hesitate to get in touch with us. If you want to become part of the committee and you think you've got a hot topic that you want to present to fellow IMechE members, then again get in touch and we'll see, we'll put you in touch with the relevant people to get that webinar done. Without any further ado, I think that is it from us. So thank you very much for all your attendance, and please go to the IMechE media website for any future events. Thank you very much.
Thank you.
End the event.
No, you just stop recording.
Stop
Thanks.
recording. Stop recording. Stop. End event.